Hello, we are going to look at a problem dealing with a normally distributed value, and we are going to investigate what that means. So let's take a look at our prompt. It says the body temperature of non-febrile adults is normally distributed with a mean of 98.2 and a standard deviation of 0.62. So we have some really important language in this prompt. Our first piece of really important language is this normally distributed bit, and that has to have meaning for us. So something that is normally distributed means that if we created a histogram of all of the values, that histogram would end up taking on a bell-shaped curve. So I'm going to draw my best approximation of a bell-shaped curve, and I always put the horizontal axis underneath that because this bell-shaped curve actually comes from the histogram. In a histogram, we'd have our classes down here along the bottom, and then our vertical axis would be the number of values going this way. In a histogram that is bell-shaped, we know that right here in the middle is where we have the mean. And we can use the Greek letter mu to represent the mean, and our mean here is given to us as 98.2 degrees. Now let me just make a comment on that before we move on. We normally think of body temperature here in the United States as 98.6 degrees. That 98.6 degrees came from studies that were done using the mercury thermometers. Nowadays, when we use the digital thermometers, we have not been able to hit that mean exactly. However, the mean that we do find in studies is not so far off that we've changed our protocol. So in this particular set of data, which was a very large study done, the mean was 98.2. Now, moving away from that side note, back to our problem. We are told the standard deviation is 0.62. We know that almost all of our data will occur within 3 standard deviations. So what I do is I mark off this half of the axis into approximate thirds. And so this represents 1 standard deviation. That's not a 0 or a 10. That's the symbol for the Greek letter for standard deviation. 2 standard deviations and 3 standard deviations above the mean. And the empirical rule there tells us that about 97% of our data is within 3 standard deviations, 99.7. So I do the same thing here because of the symmetry. I mark off 3 standard deviations. These are below the mean, so I'm going to use -1 standard deviation, -2 standard deviations, and -3 standard deviations. Now, this is the standard, but each of these have a temperature associated with them. Here where the mean is in the middle. The mean technically would be 0 standard deviations because the standard deviation says how far away from the mean is itself. So this is my 0, these are higher, these are lower. The way that I find these values over here is that I would add the standard deviation, so plus 0.62. So this first temperature on my calculator, I'm taking 98.2 and I'm adding 0.62, and so I get a temperature of 98.82 degrees. So then if I want to know what is the temperature here at the 2 standard deviations, well, that means I have to add the standard deviation 2 times. So I take 98.2, add it once, and that gets me this number. Add 0.62 again, and I get 99.44 degrees. And so to get the number at 3 standard deviations, I add the standard deviation one more time, and I get a value of 100.06 degrees. So these tell me the actual temperatures that would appear at 1, 2, and 3 standard deviations above the mean. On the other half of the normal curve, these are all below the mean. So in order to figure out them, I would subtract the standard deviation. So I'll start here with 98.2 again in the middle. This time I'll subtract 0.62, and so I get a temperature of 97.58. And then I'll take that answer and subtract the standard deviation again, so I get a temperature of 96.96. And I subtract one more time, and I get a temperature of 96.34. And so I have the values here in front of me that show that 99.7% of all temperatures for people who do not have fevers are going to fall between 96.34 and 100.06. However, from -2 to +2 standard deviations, the empirical rule tells me 95% of people fall in there. So 95% of people, if we just take their temperature, it would be between 96.96 and 99.44. So once we have these values and we know that the data is normally distributed, we can start to predict a certain percent of people that fall into each category or section of this normal curve. So let's take a look at our very first question. It says expect blank percent to have a temperature below 98.2. So I look where 98.2 is on my picture, and 98.2 is right here at the mean. And I know that the mean is in the middle because the mean, the median, and mode are the same with normally distributed data. I know this graph is symmetrical, and so I would expect 50% of the temperatures I take to fall below. I would also expect 50% of the temperatures I take to be above. All right, so let's take a look at the next one. It's expect blank percent to have a temperature above 100 degrees. As I look here on my picture, 100.06 is here at 3 standard deviations, so 100 degrees must be very slightly below that. I can tell because of where that's located that only a very, very tiny percent of people would have a temperature above 100 if they didn't have a fever. So let's take a look at the math to figure this out. So the first thing I'm going to do is calculate a z-score. So my z-score formula is to take the value I'm interested, which is x in the formula, and I'm interested in a temperature of 100 degrees. And I'm going to subtract the mean from that, so 98.2. And I'm going to divide that by the standard deviation, so 0.62. So I go to my calculator and do that math, and I get an answer of 2.9. And that's very much what I would expect because the z-score tells me how many standard deviations. So if I label that, I use that Greek letter. And so right here, right before 3, here is a temperature of 100 degrees, and the z-score for this is 2.9 standard deviations above the mean. The question asks me, what percent do I expect to be up here, to be higher than that? So this area is my question. What percent of people fall into that section of the graph? Well, in order to answer that, I have to go and look up what a z-score of 2.9 translates to. So I look at my table. I know that I can use the same numbers for the negatives and the positives because of the symmetry. So I look up negative 2.9 and I get 0.19%. Now when I look at the label up here, it says the percent below the given value, but because I'm dealing with a positive, it is also the percent above the given value. So going back to my problem, maybe. There we go. This area represented 0.19% of the graph. So less than 1% very, very rare for someone to have a temperature above 100 and not have a fever. Let's take a look at the last, let me write my answer up here and then we'll take a look at the last one. So we have 0.19%. Our last problem says we expect blank percent to have a temperature between 98 and 99. So I'm looking on my graph for where 98 would be. Here's 98.2. So 98 would just be a little bit below the mean. So probably about here, 98 degrees. And 99 would be somewhere in between 1 and 2 standard deviations, maybe about here. Well, to figure out exactly where those guys are, I need their z-score. So I have to do them one at a time. Z is equal to 98 minus the mean of 98.2 divided by the standard deviation of 0.62. And doing that math on my calculator, I come up with a value of negative 0.3. Negative makes sense because it was below the mean, and anything below the mean should have a negative value. Also have to do the z-score for 99. So 99 minus 98.2 divided by 0.62. And do that math on my calculator and I come up with a z-score of 1.3. And again, that makes sense because that was in between 1 and 2. We weren't exactly sure where, but somewhere in between there. So then I have to go back and look both of these up on my percent chart. So negative 0.3 is 38.21% right here. And 1.3 is over here, 9.68%. So I'm going to take both of those numbers back to my problem. So this one gave me a percent of 38.21%. And this one gave me a percent of 9.68%. So I have to think about where are those numbers on my picture. So when I read on the chart, it was percent below given value. So this 38.2% is down here. And this, by symmetry, would be above, so that would be 9.68% up here. But when I think about the area I'm asked for in between. So I want this section. In order to find that section, I know that the entirety of the data is 100%. I don't want the lower section, so I'll subtract out 38.21% because that is too low. And I don't want the higher section, so I'll subtract out 9.68% because that is the part that's too high. And so I do that math on my calculator, and I figure out that 52.11% is between. So I have the answer to my question. I would expect about 52.11% of the temperatures to be between 98 and 99.